function f of x is given by the equation f of x plus f of 1 over 1 minus x equals x, where x is a real number other than 0 and 1. Find the closed formula for f of x. Requirement x is different from 1 is obvious, as value 1 turns denominator into 0, so the argument becomes infinite. The second term is undefined, so is the first term, which is f of 1. While value 0 at start seems alright for x, substituting 0 for x gives f of 0 plus f of 1 equals 0. And since f of 1 is undefined, f of 0 is also undefined. This explains why both requirements are essential and hopefully will be a good hint for solving the problem. So, let's make the second term looking exactly like the first. How? By the following substitution. X equals 1 over 1 minus y. Now we need to express the second argument in terms of y. Start with 1 minus x, and we can see that 1 and 1 are cancelled out, and we get minus y in the numerator. In order to get positive y, we multiply numerator and denominator by minus 1. What we need is actually 1 over y minus x. So the expression has to be inverted, and after dividing term by term, we get 1 minus 1 over y. Now we are ready for the substitution, and we get the following equation, and here it is quite obvious that y cannot be neither 0 nor 1. Now the sneaky part. Given that y is just a variable having the same area of definition as x, we can replace letter y by letter x. This brings us to the equation number 2. Why I'm going to wipe out the obsolete lines, think about what can be done next. Back to the equation number 1, but this time we turn the first term into the second. So we just take the second argument as y. Now we need x for substituting into these two places. So we have 1 minus x equal to 1 over y. And then we find x. Now we substitute into the equation 1. And again, y is not 0, but y can be also 1, as for y equal 1, the first argument becomes 0 and f of 0 is undefined. And of course, we again replace letter y with letter x, and we get equation number 3. We have three equations where each term at the left-hand side appears twice. F of x, f of 1 over 1 minus x, and f of 1 minus 1 over x. So if we add up all the equations, we get twice the sum of three terms in the left-hand side. And then we of course divide by 2. Meanwhile, I merged x and 1 into the same term and change the order for 1 minus x. we now have x minus 1 and minus at front of the fraction. Then we reduce to common denominator and we distribute. Here we get x squared minus 1 multiplied by x gives x cubed minus x and some more term. We add similar and we get this nice expression. And we write the result as equation number 4. Here we are at the final stage. Equation number 4 contains the sum of 3 terms, but what we need is actually the first term, f of x. We see that equation number 2 contains just the terms we are going to get rid of. Therefore, we just subtract equation number 2 from equation number 4. And after reducing to same denominator and merging similar terms, we finally get the expression for f of x. This seems to be a good place to stop, but we check that the formula is correct and the original equation is satisfied. So we substitute and then multiply both numerator and denominator by 1 minus x cubed. And then we distribute numerator, merge the similar terms, and finally multiply numerator and denominator by minus 1. So the denominator for both terms in the left hand side will be the same. Now we can add them up and we see that minus x and x cancel out, plus 1 and minus 1 cancel out, and we get just 2 terms in the numerator. Then we factorize, reduce, and ta-da!